Okay, so simply what we're going to do today, this is about as mundane as you can get, but a lot of people want to see videos of filming firearms milling. I get a lot of questions for that, and I really don't film a lot. It's not because I don't do it, it's just because this takes me about 5 times as long, and I didn't think it would be that interesting to people to just see metal chips fly of gun parts. But today we're going to be milling this Trijicon RMR into this Glock 21. So this is a 45 caliber Glock, the thicker or wider version of the Glock slide. So the 19s, 17s, 26s, 27s, all of the other Glocks have almost exactly the same width of the slides until you get down to the single stacks like the Glock 43s and 48s, but the 45 caliber Glocks are quite a bit thicker, and it actually the RMR nests a little bit better into it. It's almost perfectly flush on the sides here after it's milled, which you'll see. This optic does hang off just a little bit on the edges on your Glock 19s and even your Smith & Wessons and basically any other firearm. Just this is pretty wide, so it works out really well. So that's what we're going to do today. First I'll walk you through just getting it set up and zeroed in the mill, and then we'll cut something. Alright, so turn the computer on. That's my regulator to the air just for the mill, so specifically to the air blast for the mill. So I keep that off because the solenoid valve for it, until the computer software is energized, doesn't stay shut. So if I were to apply air to that right now, it would start pissing air out of the airline until the solenoid resets. So wait till the computer boots up all the way. Okay, launch LinuxCNC. And you can see here all of these numbers are red. That means we haven't yet homed the machine. So I'm going to take it out of e-stop, and right now the machine is enabled. So I can move the axis and you can see the numbers change, but they stay in red, and that's because the machine isn't homed yet. So on LinuxCNC, down here we can home the machine. This button would be if you have limit switches to home all axis. I don't, so that doesn't do anything because I haven't coded it to do so. I'll eventually get limit switches, maybe. I don't know. You'll see here that it's not really hindering me at all. So I keep the Y and Z at their home position. Z direction, so Z all the way up, and Y as close to us as it'll fit with the doors closed, so the vise doesn't hit the doors. So the only thing I really have to change is move the X and then zero that. So on the software here right away. So really all I have to do is tap Y and Z, and you can see that they went white, meaning they are homed. From here I'm going to hold Shift and the right arrow. I'll show you over here. I just hold Shift, which is rapid movement in LinuxCNC, and then left, right is the X-axis. So I'm going to hold Shift and the right key, which, if you haven't done this before, right is from the spindle's perspective. So the spindle is going to move to the right, or the head is going to move to the right, the way the control looks at it. So obviously the head doesn't move left or right, so that will cause the table to move left. So again, I'm going to hold Shift and the right arrow, and the table's going to move, and I'll get you over here. I zero my machine just so that bumper for the bearing touches the glass, which is right there. Doesn't need to be super precise. You can see I now have my X-axis all the way to the left, and I'm going to hit this button and home the X. So here all of my axes are homed and the machine is enabled and ready to go. So I'm going to turn the spindle on, Okay, it's on now, and this is probably the most important step to avoid crashing your machine. Right now, tool 99, or my Heimer, is in the machine. It's always the tool that I start off with because I'm going to set a work offset. But if you look at my tool information, it thinks that tool 0, or no tool, is in the spindle, and that could be catastrophic if you try to set your work offset and it doesn't know what tool it's setting it based off of. So I'm going to open the tool editor page, and you can see right here the first tool on the list is tool 99, and that is my Heimer with the correct Z offset in it. So select that. This button here would be if you were going to do a manual tool change, which is all I can do on my machine. I don't have an auto tool changer, so I hit that and it prompts me insert my Heimer into the spindle and click continue. It's already in the spindle, so I hit continue. And there. Now you can see that tool 99, or my Heimer, is in the spindle. So that is half of the way there. And this is really the most important step to avoid crashing your machine. If you'll notice, my diameter offset is 0, which is normal. I don't do wear for the diameter of a probing tool, so that should always be 0. But the Z offset should be this number here that you saw, 4.987 inches, because that is my height offset for that tool. And that's very important to make sure that you see that in there before you use the tool to set a Z offset. So I'm going to go to MDI. The reason that's not showing up is because I haven't told the control to enable height offsets in the machine yet, which is G43. Nice thing with LinuxCNC, it actually remembers, if I can drag, there we go. It remembers all the codes that you've typed in, so I don't know how far back this goes, I've never really checked, but quite a bit, and I can easily recall one that I've used recently. So G43, and if you watch the number right down here as I hit OK, now that Z offset is enabled. So the machine is enabled, all the 3-axis are homed, and I am ready to move. I like to get my graphics display sort of centered here. So that's the work envelope of the machine and where the current work offset G54 is relative to the area of the machine, and there's no toolpath loaded, which is why you don't see any lines for toolpath. So the machine is now started up and ready to go. Okay, so make sure that the vise, first thing always, make sure the vise is clean, free of chips. I came through and wiped this off with some alcohol because it's the first thing I'm cutting today. And then get your parallels nice and clean. Something OCD that I do, again, you probably can't read this, but this is the lettering. I always make sure it's facing upright and toward the center of the jaw. Literally makes no difference, but I like to do things the same way always. And I actually just felt there a chip that I brushed out of the way, so I slide these in from one end to the other. I saw this trick from Peter Stanton over at Edge Precision. It makes a lot of sense. If I did miss a chip like I just did, cleaning out the vise jaws, that will hopefully brush it aside rather than trapping it under the jaw and giving you an uneven height. So these are 6-inch parallels in a 5-inch vise, so I have them hang over on the left, which is where the forces are going to be from cutting. Slide the slide in, and I keep some, this is 2000s thick brass shim stock. When I'm not going to refinish the slide, which on this one today is just going to be cold blued, I will always try to protect the finish, so that stock Tenefer finish. So I just slide those in there, make sure it covers the whole length of the jaw, and there won't be any marring issues there. So now that it's set in here, I'm just going to tighten the vise jaws a bit. I have my wrench in here. Sorry. And I'll show you. So this is loose. I'm going to give it just a bit to prevent it from moving anywhere. You don't need to crank down on this and try to deform the slide with all your mights. Just a good firm amount of pressure. And then from there, I'm going to tap down the vise jaws, or the slide. So I'll put my handle back, grab my dead blow, and they always say one good whack. I usually give it a couple. One here. Make sure that the parallels don't slide in and out, which they don't, so it's seated in there nice and firm. Now I'm just gonna get roughly centered left to right, and then set the Z0 on this Heimer, bring it in a little bit closer so you can see this. So I'm at 60 inches a minute now. If I click that, it goes to the turtle. Now I'm at 1.5 inches a minute. A quick way to change your feed rate. Did that a bit preemptively, so I'm creeping down right now. So there, I just touched off, and that is good enough. So looks like I am 2/10 high. If you can see that straight on, which is plenty for me. So so how you set your work offset, I am under G54, which you can see right here, which is the normal first work offset that you're going to use. Click my work offsets, and I'm going to 0 that for Z. So I'm not going to set it to a specific height. My Z offset right here of 4.987 inches is going to deal with the difference in spindle nose to the height when the Heimer is zeroed. So that distance right there is 4.987 inches. So once this reads 0, I am perfectly zeroed, and I don't have to adjust it in the control. Something I always do here, and you'll see if you watch the indicator, I'm going to move left to right here, and you can see I am within probably a 0.5 thousandth, so I'm about 2/10 high over there, and about 0. So yeah, maybe 2/10 to a 0.5 thousandth off left to right, which is nothing for this project here. So now that I have the Z set, I'm going to come up off the surface, and I'm going to do the Y. So make sure that you're on a flat, and same procedure as before. And Y, come back off. And I always set my work offsets on these slides in the center of the slide. These, believe it or not, I mean, Glock is a great company, but they have tolerances just like the rest of us, so not every slide, even every Glock 21, is going to be the same height or thickness or any dimension. There is variances. So if you see here, it's saying 1.1189 inches. That's the measured thickness of that slide. So I'm going to type in 1.1189 divided by 2. And that is going to set me right in the middle of that. So for anyone out there who is interested in the accuracy, repeatability of this machine, so this is a bit unscripted for me. I haven't checked this yet, so this might make me a liar. Maybe I won't film it or post it if it is. Just kidding. So I'm going to measure this. We measured 1.189, I believe it was, in the control. So I don't know if you can see that. I'll pull this off here without disrupting it. So I got 1.1189, I believe, on the control, and 1.1197 per these Shar's cheaper 1 to 2 inch outside micrometers. So 9/10,000ths of an inch I think is acceptable enough for me. So now I have my Y offset done, so I'm right in the middle, and the X I'm going to set off the back of this face. So get in here, make sure that you're on the flat. There are a lot of radiused edges on the Glock in the back here, so you're going to want to make sure you're on one of those flats. Overshot it a bit. Pick up that and X0. Alright. And that's the work offset for G54 for the Glock. Another thing I get asked fairly often is why no power drawbar? So this is not a big deal to me to have to change tools manually. Without an automatic tool changer, I don't see a huge benefit in a power drawbar. Obviously, it'll make it a little quicker to change tools. You can probably change a tool in 15-20 seconds. But typically I start changing the tool as the Z height comes up to its tool change height and have it changed within 30 or 40 seconds. So I'll show you a quick tool change. This will probably be the only one I show on camera, just so you get an idea. So I use this adjustable wrench on the flats up here and actually just spin that so it pins against the motor, so the spindle is not movable in that direction anymore. And then I have a 14 millimeter 16 point or 12 point wrench here. Put that on the drawbar and 1/4 of a turn. Pull pops out. Switch this over to the other side. Grab my tool 11. Make sure it's seated. And that is it. So, like I said, I mean that probably took me a minute and a half going slowly and showing you. It takes me typically about 45 seconds to do that. It's not really a big deal to me, so I don't think I'm going to bother doing an automatic tool changer, a power drawbar, unless I decide to upgrade to an automatic tool changer. So now that the tool's changed, position my air blast, and we're ready to rock. Alright, so this is a Glock 30, which is a little bit shorter than the Glock we're working on today. This one does have modeled up some other slide cuts that I did for a different customer, so you can ignore all of that. All we're interested in today is this RMR cut. So the reason I chose this slide to do this with, so if I inspect the distance between the two sides, I have 1 1/4 inches here, which is a bit wider than the slide that we're about to cut, which is good. You always want to make sure that the model thinks the piece of material is larger than the actual material you're cutting, so you don't accidentally encounter extra material with the tool. So the first thing we're going to do with that 3/8 inch 5 flute Lakeshore carbide end mill is we're going to come in here with an adaptive. We're going to clear out all of that material. This is an 1/8 of an inch deep that we're cutting this pocket, so 0.125 there. You can go a bit deeper, but so one thing that some people don't take into account, you have this plunger hole going back here. This is what holds your extractor in. That hole goes straight through from the rear of the slide up to this extractor recess right there. If you drill this hole too deep, and that's a number I'm going to let you figure out by measuring it on your own, because I don't want to say a number out there and have somebody mess up a slide, but I don't personally like drilling into that hole. So there are people out there that do it. If you use the correct length screw and it doesn't protrude into that channel, it probably won't cause any issues, but it's not something that I want to do. I don't want to have a hole through the slide that I didn't mean to put there, and if you use the right hardware, you can get around that. So it is a bit of a hindrance, because I do use a longer screw on the left threaded hole than I do on the right one, but it's something that I think is important to me, and hopefully my customers appreciate that there's not a random hole in their slide. So once I do that, I'm going to come back and do a contour with a cleanup pass on it, so a spring pass, and that's something that I actually walk in. So you'll see here, the machine is cold right now. I just turned it on, as you just saw. All things grow with heat. There's no heat put into the machine yet, so right now it is going to make parts a little smaller than what it normally would. So I start with this at the smallest dimension that I think will cut the pocket, and I can always come back and do a couple cleanup passes. I like to get the RMRs on a slide where I'm not going to Cerakote it to be just basically almost a press fit in there. So that's what this contour pass is going to do, and we may end up coming back and doing one more cleanup. I'm going to spot the holes with a 140-degree carbide spot drill. Come through, and I'm going to peck drill the 632 screws. I'm going to thread mill here these screws, so I'm going to do this in a significant number of passes. These thread mills are expensive and tiny, and I don't like to break them. I found a recipe that works great for me. This single thread mill is probably done, I don't know, 150 holes and hasn't broken, so it's getting to the point where I'm going to have to replace it because it's wearing out, and I'm starting to walk that wear offset out a bit. But I like this recipe, so I'm okay with the 7 minutes it takes to make 2 threaded holes, which is pretty significant. And then this suppressed tool pass that I have right here will be, again, everything grows as we go. I also like these threads to be perfect. I mean, I like to, there's a bit of a little secret sauce that I have that I do with these threads, but they're a light press fit once they are, or light interference fit once they're fully threaded in, and that's all I'm going to say about that. But I do like to make sure that these fit just the way I like them, so I start again small, and then I'll come back through and do a cleanup pass to get these the correct fit that I'm looking for. Once the machine's warmed up and running, if I'm doing 10 or 15 slides in a day, once I set it, I don't have to go back and do that. But right now I'm not going to wait for the machine to warm up. I'm not going to do a warm-up cycle because this is the quick and dirty way that I do it, and it works for me. So that's what we're going to go ahead and do today. Run through a simulation here, turn the model off, so you can see I'm going to come through with this 3/8 inch end mill, clear all that material out. You can ignore that hole right there, that is an error in the model. Drill, thread mill, and there we go. And that's that threaded hole. Alright, so unedited, jump in here, get some chips out of the way real quick. Alright, so this is that Trijicon RMR, and let's see, this is hard to do when I'm not directly over top of it and I haven't deburred it yet. Looks like that needs to come out just a little bit. Alright, so we're back over at the computer, and let me show you how we're going to do that. So this is that contour. That's the geometry we have selected, and if you go to the passes tab, stock to leave, you'll see I left 1/1000 of an inch total, or sorry, 1/1000 of an inch on each side So that is a half a thousand or 2,000th total. Sorry, I can't speak right now. So I'm going to get rid of that. That is a bit tighter than I'm used to, and I'm going to just take another 2,000ths off of there. I could uncheck stock to leave. I don't like to do that because I like to keep the program the same. And now that that is done, I'll just post the code with this toolpath suppressed. It's a quick and easy way for me to do it. The right way to do this would be to adjust a wear offset in the machine. But like I said, I'm doing this because I haven't warmed up the machine yet. It's not because that end mill is smaller than 3/8 of an inch, although it probably is, but it's not because it's wearing, it's because the machine needs to warm up. So that's how I like to handle this, and then once the machine is warmed up and ready to go, that 1,000th stock to leave is perfect for the way my machine is set up for the fit that I like. So I'll go ahead and select, so like I said, I can just suppress this toolpath. Yes, I want to suppress it. Post this using my cloud posts. I keep it the same number. I have this connected to the cloud. So this is a shortcut to the URL of my machine. In CNC posts, save it. Yes, I want to replace, and that's all I have to do. Okay, we have reloaded the toolpath, and let's run that again. So you can hear that's taking off material. Sorry, try to get you centered. And again, that should be about 1,000th of an inch on each side for a 2,000th total widening of that pocket. You'll see the tool deflection, even in that 1,000th pass, you can just barely hear a hum. You can see a couple chips coming off of there. So tool deflection does make quite a bit of difference. If this doesn't quite nail it, then I will probably just go in and redo a spring pass. Take out a little more of that deflection on a lightweight machine like this that has a lot of flex. You'll notice that a lot more than if this were a big VMC. So again, same optic. Get it lined up straight up and down. Oh yeah, and that is perfect. No wiggle. You can see pushing forward, pushing back. That doesn't move at all. You can get it to sort of rock up and down a little bit, but no movement back and forth, side to side. And if you tried to put this in at a bit of an angle, it would not go in. Has to be perfectly lined up and straight up and down like that. So that is beautiful. Exact fit that I'm looking for. Your quick spot drill. Okay, so that spot pre-chamfered the holes and placed a spot for both of the threaded 632. Alright, and drill. This is a solid carbide drill, pretty moderate speeds, but you can see it breaks the chip pretty well. So this is directly after that drilling operation with this carbide drill, just to show you what I was talking about. If I can get this to focus. So you'll see there, these holes are already chamfered. That's from that 140-degree spot drill. So I like to do that so I don't have to come back with another tool. It does still kick up a burr with the thread mill, so there will be a tiny little burr at the edge of these, but I do like to give a little bit of a chamfer at the beginning. It does help with that burr. Alright, so before we run it, if you've been around my Instagram or Facebook at all, you know that I have a bit of a love-hate relationship with this tool here. So this is the 632, if I can get it to focus, thread mill that I'm going to run. It has about a 40,000ths diameter shaft right here, and then I'll get this on the microscope at the end, or just insert a shot right here of that tool on the microscope. That is tiny, a little 4-flute thread mill. So That's what we're going to use to go into these holes, poke down there, and then helically interpolate out and make those threads. Alright, so I said I would take a video on the microscope of this teeny tiny little end mill, so here we go. That is a thread mill for milling 632 holes. You can see the 4 flutes on there. You can get in a bit closer. Try to focus that a little better. Yep. And you can see, like I said, this is probably milled 150-ish. You can see a little wear on the tip there. Holes, but still going strong. And for some reference, so I zero these. The shaft of that is 50 thousandths. So that is a tiny, 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 tiny tool. Not fun to work with, but pretty awesome that I have the ability to do that on this mill. Alright, so, unedited here, my guess is these are not going to fit. So these are 632 Torx, you can see that, that's a T15 Torx screw, get it lined up, and nope. So you can see it started, and I could do this with a decent amount of force. I can get this to go down, but I'm going to want to take, honestly, I'm just going to do a spring pass of that and see where that takes me, and then I may go back and try to take another cutting pass. Okay, so we just posted that exact same code for that last cleanup pass again, so I'm going to go ahead and rerun that. And this should not take any stock, it should just be a spring pass. Yeah, and I can hear that taking material. Alright. let's see how we did with, and that took actually 2 spring passes, so I have it set to do a repeat finish pass, and that was a same depth pass, so technically that was 2 spring cuts. So there we go. Yeah, and you can see now, getting some resistance. Oh yeah, getting a little tighter, just the way I have them set. There we go, nice and loose at the top so you can start it. Oh yeah, same there, starting to get some resistance. Beautiful. Beautiful, beautiful. Alright, and that is one RMR cut complete.